Alright, this is our Trig Substitution Lab practice. So basically what's going on is if we see anything that has these forms, this is the substitution we're going to make. So a sum of a variable and some other number squared, or sorry, a squared variable and some other number, we're going to substitute the tangent. If it's subtraction, it's all about the location of the x. If the variable comes first, we're going to use the secant. If the variable comes second, we'll use the sine. Alright, so for this first one, we have subtraction. Alright, we have the variable second, so we're doing a sine substitution. Alright, so that's the way these first few are going to be, is they're going to be sine. So we're going to let x be a, which a is the square root of this thing, so 4 times the sine of theta. Alright, now a couple things that means. One is dx, this right here, dx d theta is 4 cosine theta, and then we split it apart, dx over there, d theta here. So 4 cosine theta d theta. Another thing that it means is x squared equals 16 sine squared theta. Okay, and that's what we're going to substitute in right there. But we also get that if we divide both sides by 4, we get the sine of theta equals x over 4. Now if I make myself a right triangle, alright, and call this theta, sine is opposite over hypotenuse, so there's the x, there's the 4. That leaves this side right here to be 16 minus x squared if you use the Pythagorean theorem. Right, and right there's 16 minus x squared. Okay, so if we can get this thing I said, now we could just substitute in, but we could also come up with a trig function that uses the integrand right here that we see and just a constant, and then we can just do a substitution on that. So if this is the sine, x over 4, well the cosine of theta is equal to the square root of 16 minus x squared over 4. So if I divide by 4 and multiply by 4, now I have this is the cosine, okay, and then I have dx is also the cosine. So when I make my substitution, I've got 4, the integral of this yellow is the cosine, so cosine theta, dx is 4 cosine theta, d theta, so another 4 cosine theta, d theta. I'm going to let this 4 come out and join the 4 that was already there. So that's 16 times cosine squared theta d theta. Alright, and then you can use your table of integrals. You can also just use a double angle identity here to get this one if you wanted to, but whichever way you do it, you're going to come out with 1/2 theta, or 16 times 1/2 theta, or theta over 2, plus sine of 2 theta over 4. Alright, plus c. But then I'm going to use a double angle identity right here and say that this is 16 times theta over 2 plus sine of 2 theta is 2 sine theta cosine theta all over 4 plus c. Now, why would I do that? Because we know what, if you look up here, we know what sine theta is, and we know what cosine theta is. Okay, so the reason I would do that is to get back to to the original variable x. Alright, now cleaning up a little bit, we're going to distribute that 16 through. So that's going to be at 8 theta plus the 2 and the 4 reduced to a 2, so again we're going to get an 8 sine theta cosine theta plus c. Alright, and now take everything back. We need to figure out what theta is. So going back up here, sine theta equals this, so that means theta is the arc sine of x over 4. So there is theta. So we get 8 times the arc sine of x over 4 plus we get 8 times sine. You go back up here, there's your sine x over 4 there's your cosine square root of 16 minus x squared over 4 plus c, and then cancel out what you can. We can get rid of that down to 2. That 2 will cancel this, make that a 2 down here. So I can say that this is 8 times the inverse sine of x over 4 plus x times the square root of 16 minus x squared over 2 plus c. Alright, next one. We got, where's my phone? There it is. We got another substitution that's going to involve the sine because the square variable follows the constant right here. So we got another one that's going to involve the sine. So I'm going to say y equals, again, the square root of this number was 5, that's our a, times the sine of theta. Okay, so once again that means dy is equal to 5 cosine theta d theta. That means y squared, if you want to do a direct substitution, equals 25 sine squared. Alright, and it also means that the sine of theta equals y over 5. Okay, so if I make my right triangle here, there's theta. That means this is y, this is 5, opposite over hypotenuse, and that means this adjacent side would then be 25 minus y squared. Alright, now this thing down here is in the denominator. The square root of 25 minus y squared is down here in the denominator. Alright, the 1/2 power is the square root. So since that's down in the denominator, up here the last time when we made a substitution it was in the numerator, and so we used cosine. Okay, but in this problem it's down in the denominator. Alright, so if we're going to do it this time we would need to use secant, okay, since it's down in the denominator. So this is on top, the constant's on top, this is down in the denominator, so that's going to be the secant of theta is equal to 5 divided by square root of 25 minus y squared. Alright, now notice that this is not just the 1/2 power, it's not just the square root, it's the 3/2 power, which is the cube of this. So if I cube both sides, the secant cubed equals all of this cubed. I get 125 over 25 minus y squared to the 3/2. Alright, so again, if I bring in a 125 and then out here a 1 over 125, then with this and this, I have the secant cubed. Okay, with y squared, I get 25 sine squared. Oops, sorry. I get 25 sine squared from y squared. Alright, and then dy is 5 cosine theta d theta. So I'm going to substitute all that in. I've got the 1 over 125 out front. The integral of the yellow is just the secant cubed. Alright, the blue is 25 sine squared theta. Alright, and then the green is 5 cosine theta d theta. Alright, now a couple of good things happen immediately. One, your 5 and your 125 multiply to 125. Sorry, 5 and 25 multiply to 125, so they wipe that out. Alright, and then remember, secant is 1 over cosine. So this is sine squared theta cosine theta d theta. So this cosine will wipe out one of these cosines, and we got a cosine squared, and so we're left with a sine squared theta over a cosine squared theta d theta, which is tangent squared. Alright, and then if you just use your sheet from last time, we got again, you can just use a double angle identity, but if you use the tangent squared x dx, the integral of that is our tangent theta minus theta plus c. Alright, now once again we need to know what theta is. So sine of theta equals y over 5. Alright, so that right there gives me that theta equals the arc sine of y over 5. Alright, and then tangent theta is opposite over adjacent, so y over the square root of 25 minus y squared. So tangent theta equals y over the square root of 25 minus y squared. Theta equals the arc sine of y over 5. Alright, and then the plus c. Alright, next one. Oops. So this is going to be another sine one. So we've got 9 minus x squared here, so we're going to let x equal 3 sine theta. That makes dx equal to 3 cosine theta. That makes x to the 4th down here equal to 81 sine to the 4th theta. Alright, and then if we make our triangle, we're going to have the sine of theta is equal to x over 3. So there's theta. So that makes opposite over hypotenuse, x over 3. That makes this 9 minus x squared. Okay? That's up top. So once again, I can make cosine theta equal to adjacent side over hypotenuse. So 9 minus x squared over 3. So I can bring in a 3 down here, right, and then multiply by 3. Hey, this is problem 3. We'll just pretend that that's what I multiplied by. Alright, so now I've got something that looks like this. Look, is the cosine theta. So there's the 3. There's the square root of 9 minus x squared. Alright, the x to the fourth is 81 sine to the fourth. Alright, and then dx is 3 cosine theta. Alright, so I make my substitution. I had the 3 out here in front of the integration symbol. The yellow is just the cosine, so I'm going to say that's the cosine theta. The green, x to the fourth, that's on the bottom. Okay, so make sure that you are putting it in the right place. That's 81 sine to the fourth theta, right, on the bottom. And then the dx, oops, forgot the d theta. Alright, the dx is 3 cosine theta d theta. Alright, so there's what I get when I do my substitution. Alright, this 3 here and this 3 will cancel out and give me a 9 down there. So I can bring a 1/9 out of here. Alright, and then cosine theta. This is cosine squared theta. Alright, and then I'm going to split up part of this sine and say that's sine squared theta there, and then the other one I'm going to say is right here. The other two, that is. Alright, now that I have a cosine and a cosine, these two combine together to be the cotangent squared theta. And then this is this sine right here, 1 over sine is cosecant. Alright, now from here, what I want to do is I'm going to do a u substitution here. Right? The derivative of cotangent is negative cosecant squared, so I'm going to say u is equal to cotangent theta. That means du is going to be negative cosecant squared theta d theta. Okay, so if I bring in a negative here, so I'll have that negative for the cosecant squared, and bring in a negative here to compensate. Now this, all of this right here, is my du. Right? And then the cotangent is my u. So with that u substitution, I end up with negative 1/9 the antiderivative of u squared du. Alright, and then the antiderivative of a function to a power is, using the power rule, we get u cubed over 3 plus c, and then combine your denominators and you get negative 1 over 27 u cubed plus c, and then u is the cotangent. So negative 1 over 27 times cotangent cubed theta plus c. Alright, now we went back one variable. We went back from u to theta. Now we need to go back from theta to x. Okay, so the cotangent of theta is adjacent divided by opposite. So 9 minus x squared over x, or square root of 9 minus x squared over x. So down here I'm going to say that this is negative 1 over 27. Cotangent is the square root of 9 minus x squared over x cubed plus c, which is negative 1 over 27 x cubed. I'm going to erase this negative 1, so I'm not going to need it. And then I can bring in, since this is a 1/2 power and there's a 3, I can say that this is 9 minus x squared to the 3/2 power. Alright, cube that x and then just multiply by the constant. So negative parentheses 9 minus x squared close parentheses to the 3/2 over 27 times x cubed. There's my antiderivative, and then the plus c.